Hello everyone, in today's tutorial I will show you how to simply implement in Opencv 4 Plus the multiple object detection in deep neural network module, and I will use model from Yolo Darknet, especially Tiny3. And as you know from the previous tutorial, I'm using FFmpeg to record this video, these videos on YouTube, and I'm using this kind of command, FFmpeg, grab the desktop, grab some audio from my Superlux microphone and produce this video output. Simple and very useful, without any graphic tool. Okay, you can find the tutorial on funvision.blogspot.com, and the tutorial is called Simple Opencv Yolo Darknet Object Detection in DNN module, and actually it goes into very detailed description how to set up the project in Visual Studio, where to download models, your free tiny weights and configuration, and how to prepare the project, very detailed description of the code and each step in the code, and full tutorial code included. It's very simple. It's under 100 lines of code, and I will show them in action. And here is the prepared place for this video, which I'm currently recording. And let's jump into the Opencv and start with the configuration. And now to Opencv, let's jump into Visual Studio. But you understand. Okay, in C and C++ setting, we are always setting additional include directories, and this additional include directories point to Opencv 4.2, my build 3, which is custom build with GS streamer, and what is important, the contribution modules, especially DNN, and the headers are in that include directory. In linker, we are always try to set the additional library directories, which is under Opencv 4.2 build 3 install version of Visual Studio vc16.or/lib. And in input, in additional dependencies, I will open this variable. We have a car library, video, DNN from the contribution modules, video IO, high GUI, and EMPROS. That's all from configuration. And in a header file, this is very common, and this DNN module is from contribution library. I'm using this namespace. It will simplify my code in the next steps. Here I will, if I have time, I will get back to that later, but it's not described on that tutorial code, because this is in progress, and tutorial code starting here. I'm capture basically this movie sample, and maybe this is what I would like to show you. In directory where I'm producing the DNN exe, which is output of this project, DNN CPP, I have copied the DLL libraries from Opencv. This this is for I can skip configuration of the let's say of the path configuration to DLL libraries of Opencv, environmental path variable, and I have as well the input which will be processed by this program, and I have as well stored the model for a YOLO3 tiny weights of the neural network and YOLO3 tiny configuration for the neural network. And all is here, and I'm basically loading these three from that location and using in the network, I'm reading this network defined by this model, which is weight of the network, by the configuration of this network, and backend is the darknet. Here in what is the preferable backend and target, you will, let's say, read on the blog post in more detail what is it good for. And in main loop we are just, let's say, grabbing a screen from this video into image container here and producing something which is called the blob. Blob is basically 4D object for a four-dimensional math, and from this image you will produce this blob. And I'm not normalize the blob here, and the blob image, the image inside the blob is of this, let's say, size, weight and height of this size, which depends on the neural network you are loading, the YOLO3 tiny model, using the input layer of exactly this size. I'm swapping the red and blue channel because the Opencv is producing standard RBGR instead of RBG, and this is why I'm here in that blob from image, basically swapping two channels to get red, green and blue channel image. And this is ready to be processed, and I'm basically setting input layer of this neural network in this step. Set input as input is a blob. Here is a scaling, basically, you know, all the variables from 0 to 255 of intensity for each channel RGB needs to be transferred into float variable between 0 up to 1. That means that all the intensity is just a double or float matrix with values like 0.5 or something like that. And this is done by this scaling. All the values with this maximum will be scaled from 0 to 1. And this mean is basically suppressing the mean. It's described what is these two guys doing, but this scale is definitely important. This is not that important. And once you have set input of your neural network, is ready to be evaluated, and the output is in output matrix. We will basically perform the forward evaluation of this neural network and store the output in this output matrix. And you need to process this output matrix, and this output matrix is in a format of region proposal, and basically the number of rows corresponding to number of proposed region, and the column really depends on number of class your model can evaluate. And each row, as I said, is basically one detection, one proposed region, and here the first four elements are x, y, weight and height of this region, of this proposed region, and after is just number, which basically evaluates what class most probably is inside that proposed region. It's just the number, and the index of this number corresponding to concrete class. That means there is several. For example, if I copy this one here, we will have inside that output math 2 proposed region, and right now if I will find the biggest number here, it will, it could be 0.8. If I will find the biggest number here, it will correspond based on the index to the class 2, and I can display x, y, y, and h rectangle with some label corresponding to class 2. For the second purpose region, I will find the biggest number somewhere here, and I need to name this rectangle based on the class 3. And we will get into the loop where we are processing each of these rows, each of the proposed region. Here, basically, we are skipping this x, y, and h, and produce the new matrix just based on scores for each class. And by min-max log, we are finding this higher number in scores matrix and index which correspond to class in that score matrix. If this found highest number exceeds some threshold, we can display this. And here I'm taking the first number of the row, second number of the row, another number of the row, and another number row, and it's basically x, y, and weight and height of my rectangle. No, x, y, weight and height. And here I'm just displaying this. I will, instead of translating the index of the location of the class, the highest number, translating into some string car and people and so on, I will just display this index, and it's a simplified code, and I will draw this rectangle, and the last thing, I will display the result. It's very simple. It's now just compile and display a result. And I have some problem with FFmpeg because anytime I'm running the Yolo network, basically my buffer will be corrupted and I will lose the stream. Basically the proposed region are displayed here in video output, and I will turn this down to not corrupt the FFmpeg, and I will continue because you can see this problem with real-time buffer, and this is when I don't have enough memory to run the Yolo neural network together with simple FFmpeg, which is shame of my 10 years old computer. And as well using this video writer here in that example, which is producing, instead of TCP/IP servicing, which I used in previous tutorials, it's using LSSync for real-time video streaming, and basically this through the video writer is producing these chunks, and these chunks basically you can reach through the web player, or let's say the HTTP server, which refers to that player list, and you will basically open one by one each of these chunks, or it will decide for you which chunk will be opened and played for you. And I will try to play just a few directly in VLC player, because this will be part of some future tutorial. Okay, there is no video here. It's strange, but in the first one I think there will be something processed. Let's play this one. Okay, we can see the output result of my example using Yolo network, and it's producing the video segment which are prepared for real-time streaming through the LSS sync. And you know, as we saw, this detected region on compiled program using this Yolo tiny model, each region belongs to X some row which have higher number at the index of this class and exceed the confidence threshold to be even displayed. And that's it. I think you can achieve this under 1 hour or something like that. And just play with Opencv. It's fun. Subscribe to my YouTube channel and Facebook channel, and follow my blog and share and